All right, in this video, we are going to solve this logarithmic equation. Log of 7x minus 2 minus the log of x minus 2 equals 1. Okay. So in the previous video, we talked about the steps for general steps for solving logarithmic equations. The first step was to make sure that all of the logs are on one side of the equation and all the non-log terms are on the other side of the equation. And so this equation has that property. All of the logs are on the left-hand side of the equation, and then the 1, which does not have a log, is on the right side of the equation. Okay. Next up, what I'm going to do then is, once all the logs are on one side of the equation, is to use the three properties of logs. Right? That's either the product rule, quotient rule, or power rule. If you're not familiar with those, then you need to go back and watch the previous videos where we've talked about those. And then we're going to use those properties, right, to rewrite this side that contains the log as a single log. All right, so here I can see that I have these two logs being subtracted from one another. That means of those three properties, the one that I want to use is the quotient rule. The quotient rule, right, for logs says that if I have the log base b of a fraction, then it's the log of the top minus the log of the bottom. Okay, like so. All right, and you can see that's pretty much what I have over this side. I have the log of 7x minus 2 minus the log of x minus 2 over here. So it's looking like this. And what I can do is transfer it over to this side or rewrite it in terms of this side over here. So that would be the log of 7x minus 2 over x minus 2 equals 1. All right, so all the logs over on the left side, I rewrote them as a single log. The reason why I want to do that is because I want to take and use the fact that y equals log base b of x can be rewritten in the exponential form, b to the y equals x. So this equation that I have over here, now that I've written it as a single log, you can see it matches this exactly. Okay. Except you might say, well, what about the base? But remember, if there's no base, it's log base 10, right? It's understood to be a 10 there, the common log, right? All right, and so what I'm going to do then is to rewrite this equation into this exponential form. So when I go to do that process, normally the first thing I focus on is the base, right? The base of the log, which in this case is 10, right, becomes the base of the exponential function on the other side, or in the exponential form. All right, so this is going to be 10, base 10. Next, I normally focus on the exponent part of it, right? The exponent in the exponential form is what the log is equal to over in the logarithmic form. So that's going to be a 1. All right, and then what is inside the log in the logarithmic form is on the opposite side of the equation in the exponential form as the exponential function. So that's all of this stuff inside here. So 7x minus 2 over x minus 2. Okay. All right, and so now that is nice, right, because the logs are gone. Now this is an equation that is similar to some of the other equations that we've solved before. All right, so this is an equation that has fractions in it. Right. Once I go ahead and simplify each side as much as I can. Yeah, there's not much to do here, right? But in terms of simplification, but 10 to the first power is just 10. The next thing that I want to do, since this equation has fractions in it, is to clear out the fractions by multiplying through by the LCD. All right, so the LCD is easy to determine in this example, right, because it is just x minus 2. There's really only one fraction in here, right, and so therefore the LCD is just going to be whatever the denominator of that fraction is, in this case x minus 2. Then what I'm going to do is to take both sides, right, and multiply both sides by x minus 2. So I'm going to take and multiply the 10 by x minus 2. I'm going to take and multiply the right-hand side of the equation by x minus 2 as well. All right. And that's what I'm going to get. Okay, and so then what's going to happen is over here on the left side, I can go ahead and distribute that 10 through the parentheses and get 10x minus 20. Over here on the right-hand side, that x minus 2 will cancel each other out, and I'll just get 7x minus 2 over here. All right, and so now my equation does not have any fractions in it. It's just a linear equation, right? The x is only to the first power. I don't have x squared or anything else like that. So what I'm going to do is try to get all the x terms on one side, all the non-x terms on the other side. So to do that, I am going to subtract 7x from both sides. That will put all of the x terms over on the left side. And so then I'm going, if I add 20 to both sides, then that will get all the non-x terms over on the right-hand side. So simplifying that out, so 10x minus 7x is going to give me 3x, and then over here I'll have negative 2 plus 20. That gives me a positive 18. All right, so now I have all the x terms on one side, all the non-x terms on the other side. I'm just going to divide both sides by 3, so I get x equals 6. There. All right, so x equals 6 is the solution to this equation. Now, you have to be very careful, right, when you do this, because even if you did everything perfectly, right, in this equation, you used a couple of properties here. We used this quotient rule property, and then we also multiply through by an expression. So even if we did everything perfectly, we still run the risk, right, that this solution might not actually be a solution, right, to this equation. So we will have to check every single answer here. There's just no way out of that. Okay. So this equation is really easy to check. It's just got it's log base 10. You can check with your calculator, right? So if you do that, log 7 times 6 minus 2, and then minus log 6 minus 2, right? So I'm just plugging the 6 in here that I got as a solution, and I click enter, I get 1. If you get an error, right, then probably what happened is that this solution is something that will make the inside part of the logs negative, right, or 0. You need to always be mindful of that. If you're not going to check using your calculator, at the very least, right, you need to make sure that when you plug in this 6, right, you don't get a negative inside there. If I plug a 6 in here, right, I get 7 times 6 is 42. 42 minus 2 is 40. And then here, 6, if I plug a 6 in here, I get 6 minus 2, that's 4. Okay. So if you did everything perfectly, that means that the 6 is a solution of this equation. The other thing you would have to check is when I plug a 6 into the LCD, what do I get? When I plug a 6 in here, I get 6 minus 2 is 4, right? And so that's non-zero. So at the very least, you need to do that kind of check. That won't catch every single mistake, right, that you might possibly make, but it will probably catch the obvious ones where, or at least, if you've done everything perfectly, it will catch the fake solutions that creep in. All right, so here the only solution is x equals 6.